Have you ever just wondered, what are the odds? From a simple coin toss all the way to these super complex models that predict the weather, there's a language we use to talk about uncertainty. And today, we are going to demystify that language. Probability.
It really all starts with a question we've all asked a million times. You flip a coin. What are the chances it lands on heads? This one simple action, believe it or not, is the perfect way to start understanding how we can mathematically pin down the odds of, well, pretty much anything.
So to calculate the odds of anything, we first got to know the rules of the game. And in probability, the number one rule is that every single outcome exists somewhere on this scale. A scale that goes from absolutely impossible all the way to totally inevitable.
Yeah, you heard that right. Every probability can be boiled down to just a single number between 0 and 1. 0 means something is completely impossible. It will never, ever happen. And 1 means it's a sure thing. It is absolutely guaranteed to happen. This simple little range is the foundation for everything we're going to talk about.
So, every single maybe in the entire universe falls somewhere between those 2 points. A probability of 0.5, that represents a perfect 50-50 shot, just like our coin flip. A 0.6 would be a 60% chance, and so on. This is how we take a kind of vague idea like chance and turn it into a solid, hard number we can actually work with.
Okay, so how do we actually find that number between 0 and 1? Well, it all starts by mapping out all the possibilities. And this involves two really key concepts: the experiment we're running and what's called the sample space of that experiment.
In probability, we call any action with an uncertain outcome a random experiment. It sounds kind of technical, but it's just a term for everyday things like flipping a coin or rolling a die. The key thing is, while we know all the things that could happen, we can't be 100% sure which one will happen on any given try.
So where do we begin? We start by mapping out every single possible result. And this complete map of possibilities, that's called the sample space. You have to know every single thing that could possibly happen before you can even think about calculating the odds. Let's look at some examples, right? For a single coin toss, the sample space is super simple. It's either heads or tails. That's it. For a 6-sided die, it's the numbers 1 through 6. But check this out. When we toss 2 coins, the sample space gets a little more interesting. You could get 2 heads, 2 tails, or a head and a tail in 2 different ways. Nailing down this complete set is always the critical first step.
Okay. Now that we have our complete map of possibilities, our sample space, we can start to focus on a specific destination. In the world of probability, the particular outcome we're interested in is called an event.
Now, an event isn't some totally separate idea. It's just a piece, or a subset, of that bigger sample space. It's basically us zooming in and saying, out of all the things that can happen, this is the one I actually care about right now.
For instance, if we roll a die, the sample space is all 6 numbers, 1 through 6. But what if we only care about getting an even number? Well, that's our event. So we just pick out the outcomes that fit that description, the numbers 2, 4, and 6. See? Our event is just a specific slice of all the total possibilities. Okay, we've got all our building blocks, we know the total number of things that can happen, and we know the specific thing we want to happen. Now we can finally do it. We can calculate the probability.
And here it is, the fundamental formula of probability. It is so elegant and so simple, right? You just take the number of outcomes that you want, your event, and you divide it by the total number of things that could have possibly happened from your sample space.
Let's just apply this to our die roll. We've got 6 total possible outcomes. Our event, getting an even number, includes 3 of those outcomes, 2, 4, and 6. So we divide our 3 favorable outcomes by the 6 total outcomes. That gives us 3 over 6, which simplifies down to 1/2, or 0.5.
And there it is, a 50% chance of rolling an even number. Which means, of course, that the other 50% of the time, you're going to get an odd number. And thinking about the probability of what doesn't happen is often just as important as the probability of what does.
So we've been focusing on the probability of what we want to happen. But what about the probability of everything else? This is where this idea of the complementary event becomes incredibly useful.
A complementary event, you'll often see it written with a little dash or a prime symbol like this, is literally just everything in the sample space that wasn't in your original event. You can just think of it as the not A category.
Let's go back to our trusty die roll. If our main event is getting an even number, so 2, 4, or 6, then its complement is simply getting an odd number, 1, 3, or 5. And notice how the event and its complement together contain every single possibility in the sample space, with zero overlap.
And this leads to a really cool and elegant shortcut. Since the total probability of something happening is always 100%, or 1, the chance of your event not happening is simply 1 minus the probability that it does. We calculated a 0.5 chance of rolling an even number, so the chance of rolling an odd one has to be 1 minus 0.5, which of course is also 0.5.
And just like that, with only these few concepts, we've actually built the entire foundation for how we think about chance and probability. It's pretty cool.
So what does all this mean? It means you now have the tools. You know that probability is always measured from 0 to 1. You know how to map out every single possibility in a sample space, how to define the specific event you're interested in, and how to use that simple formula to calculate the precise odds.
But see, this foundation just opens up a whole new world of questions, doesn't it? We've figured out the odds of a single event, but what about a sequence? How would you figure out the odds of flipping 2 heads in a row, or rolling an even number and then rolling a 5? That, my friends, is where the real power of probability truly begins.